We are going to look at another problem about probability distribution and mathematical expectation. A couple plans to have children until they get a girl, but they agree that they will not have more than 3 children even if all are boys. Assume that boys and girls are equally likely. Letter A. Create a probability model for the number of children. Letter B. Find the expected number of children. Letter C. Find the expected number of boys they'll have. I would like to emphasize before we do anything that there's an assumption that boys and girls are equally likely. This means that when somebody is pregnant, the probability that the baby is a boy is one half, and the probability that it is a girl is also one half. Now we are going to create the probability model for the number of children. Before we do that, however, let us look at the different situations or the different possible cases for the number of children that this couple will have. Here are the things to consider. If the first baby is a girl, the couple will not have a baby anymore. Thus, they will only have one child. Again, this will happen if the first baby is a girl. If the first baby is a boy, the couple will attempt to have another baby. And if the second baby is a girl, they will stop. Thus, they will have 2 children. If the first and the second child are boys, then they will attempt to have another child, but regardless of the gender of the third child, they will not have a fourth baby. Thus, they will have a total of only 3 children. This can happen in two possible cases. For example, one case can be a boy in the first child, a boy again in the second child, another boy in the third child. But it can also be possible that they will have a boy in the first child, a boy in the second, but for the third they have a girl. We are going to consider all these three cases when we are going to have our probability model. We are now going to construct the probability model or the probability distribution for the number of children. It is possible for the couple to have only one child, 2 children, or 3. And we are going to compute the probability for each of these cases. Let's consider, for example, the situation where the couple have only one child. And this will happen if the firstborn baby is a girl. The probability that the baby is a girl is one half. Therefore, the probability for 1 is one half. The second case is 2 children. And this will happen if the firstborn is a boy and the secondborn is a girl. The probability of having a boy is one half, and the probability of having a girl is also one half. Since these two cases are independent, then we can multiply the probability for the boy times the probability for the girl. So we have to multiply one half times one half, which will give us 1/4. So the probability of having 2 children is 1/4. Now let's look at the third case. 3 children will happen if the firstborn is a boy, and the secondborn is also a boy, and the third one is also a boy. That is one of the two cases for having 3 children, because there is also a second case where you have a boy, followed by a boy, and then a girl. We are going to consider these two cases separately. So for case 1, we have first child is a boy, second child is a boy, and the third child is also a boy. But for case 2, we have the first child is a boy, the second child is a boy, but the third child is a girl. We are going to compute the probability separately for case 1 and case 2. For case 1, the probability for the firstborn being a boy is one half. The probability for the second child to be a boy is also one half. And the probability for the third child to be a boy is also one half. If we multiply these three probabilities together, we are going to get 1/8. This is the probability for case 1. Let's look at case 2. The probability for having a boy as the first child is one half. The probability of having a boy as the second child is also one half. But the probability of having a girl as the third child is also one half. So therefore, the probability is also 1/8. These two cases belongs to the same situation where the couple have 3 children. Therefore, we are going to add these two probabilities together. Case 1 plus case 2. The probability for case 1 is 1/8. Then we are going to add into that the probability for case 2, which is also 1/8. So overall, the total is 2/8, or in lowest term, 1/4. So therefore, the probability for the couple to have 3 children is actually 1/4. Now let's look at letter B. Letter B says find the expected number of children. I hope you recall that to find the expected number of children, or the expectation, the mathematical expectation, all we have to do is multiply every specific value of our random variable times its probability, and then we are going to add all the products together. In this case, we have 3 pairs of values. So all we have to do is multiply every single value of our random variable times its probability and add all the products together. So therefore, we have to say 1 times 1/2. The probability of having one child is 1/2. Multiply them together. Next is 2 times 1/4. Next is 3 times 1/4. And then we are going to add all those products together. So here is the result if we multiply them. And here is the result when we add them. So therefore, the expected value, or expected number of children, is 1.75. Now let's look at letter C. Letter C says find the expected number of boys they'll have. We're looking for the expected value of the random variable, but this time the random variable is composed of the possible number of boys. First, we are going to construct a probability model showing the possible number of boys, and we are going to compute for the probability of each of those values. So we are now going to consider the different possibilities for the number of boys. For example, one case is all 3 boys, all 3 children are boys. So that means the firstborn, the secondborn, and the third child are all boys. However, we can also have just 2 boys, and this will happen if you have a boy in the firstborn, second is also a boy, but third is a girl. In this situation, there are 3 kids, 3 children, but 2 of them are boys. So we have 2 boys if we have boy, boy, and girl. Another situation is we have just 1 boy. And this will happen if the firstborn is boy, but the second child is a girl. Remember, they are going to stop once they have a girl. So 1 boy means a boy followed by a girl. But it's also very possible for the couple to have no boys at all. And this will happen if the first child right away is a girl. So therefore, the possible number of boys in the family are 3, 2, 1, or 0. We are going to compute for the probabilities of each of these values. Now, for the probability of having 3 boys, we are going to consider the situation where we have boy, boy, and then boy. The probability for each of that would be 1/2, then times 1/2, and then times 1/2, and that will give us 1/8. So therefore, the probability of having 3 boys is 1/8. Now we are going to consider the case where we have 2 boys. And like I said before, 2 boys will happen when there is a boy as the first child, boy also in the second child, and in the third child it's a girl. The probability for a boy in the first child is 1/2. The probability of having a boy as the second child is also 1/2. And the probability of having a girl as the third child is also 1/2. So we multiply 1/2 times 1/2 times another 1/2, and that will also give us 1/8. So the probability of having 2 boys is also 1/8. Now let's consider the case where we have exactly 1 boy. And this will happen if the boy, or rather the first child is a boy, but the second child is a girl. So we only have 2 children. The probability of having a boy as the first child is 1/2, and the probability of having a girl as the second child is also 1/2. So we multiply 1/2 times 1/2. And the answer, of course, is 1/4. So therefore, the probability of having 1 boy is 1/4. Now let's look at the situation where we don't have a boy. And again, this will happen if the first baby right away is a girl. So the probability of having no boy is the same thing as the probability of having a girl as the first baby. the probability of having a girl as the first baby is exactly 1/2. Therefore, the probability of having 0 boy is 1/2. So this completes the probability model for the number of boys. Now we are ready to compute for the expected number of boys in the family. All we have to do is just multiply every single value of our random variable times its corresponding probability, and then we are going to add all the four products together. We are going to say 3 times 1, 8, 2 times 1, 8, 1 times 1/4, and 0 times 1/2. And then we are going to add them all together. So here is the way we compute for our expected value. So 3 times 1, 8, 2 times 1, 8, 1 times 1/4, and 0 times 1/2. Then we are going to add all these fractions together. We have to make the denominators the same, and we are going to get 7/8 or 0.875. So this is the expected value or the expected number of boys in the family. I hope this example gives you a better understanding of random variables and probability distribution. Thank you.